Let's start, before I introduce myself, with a small quiz. Okay. This question is to everyone. What percentage of new products that are launched annually actually succeed? Okay. I'll make it easier for you. Here are the options: 5%, 15%, 35, 50. Just type it out in the chat. Let's see. We have a smart round here. Okay, so a lot of the folks saying 5%. I hear some 15%, some smart guesses.
Okay.
Conservative approach.
Okay, let's reveal the answer.
Highly optimistic.
Yeah, more optimistic.
Let's reveal.
There
Now,
is a
as
catch
per-
in you.
Sorry?
No. Go ahead, Vivek. No, I was just mentioning that there is a catch in new products. So because of that.
Okay, yes, this is new products for sure. This is new product introduction. So as per MIT research, 95% of new product launches fail annually. Okay, only 5% succeed. Let's look at another quiz that's related. Why do these products fail? 95% of them in the market. Let's look at some of the answers. Go ahead. Any guesses? Okay, I see A, C, A, all of the above. A, B, and C.
All of the above, it's not here, but it's there in the answer. Wow. Okay, all of them. All right.
Okay, I think these are some of the smart guesses. A lot of you are right. This was a tricky one with not a single answer. Okay, so here's the answer. Option A and B. Again, as per MIT research, right? Two major drivers. Products not solving real world problems. Second, lack of empathy for end customers. I know some of you said C and D. Why this is not an actual problem, I'll talk about later in our slides. Okay. All right. Let's deep dive. Who am I? My introduction. Okay. As you know, I'm Vivek. I'm based out of Cincinnati in Ohio. Okay. What do I do? I'm a business consultant. I work primarily in the domain of engineering and R&D transformation, consulting clients majorly for product lifecycle management. Now, what does this mean? A product right from its inception, that is innovation, ideation, to its end, the engineering, manufacturing, operations. I cater to end-to-end consulting for a product. I have a diploma from XLRI, and I am an engineer from Jadavpur University, which is in Calcutta. Okay. I've total 15 years of experience in this field, and I've worked for some of the great organizations like Deloitte Strategy, Capgemini Consulting, and Accenture Strategy. Okay. So today, whatever I'm going to share is from all these organizations, whatever I've accumulated so far. Okay. The picture that you see here is when I visited in Maryland PCS for People. They were doing a circular economy project, recycling e-waste. So I was happy to be part of that. This picture is part of my graduation at XLRI. Okay, so happy to connect with you all on LinkedIn. Just scan, happy to connect with everyone. Okay, so what are we going to talk today? Number one, we'll talk about what are the current trends in product engineering. It is very important. The engineering landscape is changing at a very fast pace. 5 years before, today, and 5 years after, unrecognizable. Now, this leads to certain challenges. We'll talk about some real world challenges that product engineering is facing today. Okay. Third, we'll talk about a case study. And this is where I wanted to show some videos. Let's hope it works. We'll talk about global energy and utilities company, how they actually utilized AI to solve some of the engineering problems. Okay. We'll also talk about a global aerospace company. It's a European major tackling AI at all levels possible, one of the pioneers in the industry. Okay. And we'll talk about how it is leveraging AI at all levels to solve some of the complex engineering problems. Okay. So let's deep dive. Leveraging product data. What are the current challenges? Okay. So leveraging product data. Learning from product data, it's as easy as it may sound, but it is more complex as we dive deeper. Information is the new oil of 21st century, and it is not a mystery to anyone. It's something that all of us echo. But how do we actually achieve them, right? We have a disintegrated landscape. Your engineering systems, your supply chain systems, your manufacturing systems are not talking to each other. Okay, and this is where machine learning and AI is taking data to new levels. Okay, and some of the examples are, for example, we're finding product anomalies. How do you find defects in the product, improving quality issues? In medical devices, DNA sequencing, it's a huge memory intensive job. How do you actually figure out new DNAs to solve some of the complex problems in pharma? AI is leveraging machine learning, right? And it's solving it out at these levels. Let's talk about sustainable product development. Another critical trend and cannot be stressed enough. Okay. Companies are bound by regulations to develop products that are sustainable. Now, what does this mean? We all cry when our IT department sends us a message, your mobile phone or laptop has been extended for a couple of more years, you won't get a new laptop, right? We all work in IT industry, we'll relate to it. But it is all to support circular economy. Reuse, repair, and if not possible to reuse and repair, recycle. Okay. Build from eco-friendly materials. This is the latest trend that we see. How do we sequence new materials, chemical elements to build new composites that are eco-friendly? Let's talk about products that are energy efficient and are not single use, right? So these are some of the examples, like aircraft that run on sustainable aviation fuel in Europe. There's a big push for aircraft that run on sustainable aviation fuel. Solar appliances catching up globally. Organic composites that are not single use are being used to build products instead of typical elements like metals, right? So AI plays a role in developing all these. We'll talk about this in a sequential manner. Okay. Another trend that we're seeing right now, rapid prototyping and agile development, right? Now, this is related to the question that we had, right? People right now are not waiting end to end to launch a full product. create a logical MVP, a minimal viable product, make and launch it, and then make it better iteratively. This is an approach that most of the organizations today are following, and it is helping them succeed in the way they are launching their products. A key example is Microsoft suite of softwares. It is probably in perpetual beta, which means every fortnight you have probably a Windows update or an Office update on your laptop, because the product is constantly evolving. Now we've talked about the trends. Let's talk about some of the challenges. Many products are complex in nature, right? And engineers have to design and plan for each part in synchronization so that the product can be designed and engineered. Let's take a example of an aircraft. Okay, a typical aircraft can anywhere have hundreds and thousands of millions of parts. Okay, so a single jet aircraft, let's say like an Airbus 320, right, has 340,000 parts. Huge number of parts, and each of these parts need to be designed. Okay, if I talk about a wide body aircraft, like let's say a Boeing 777, right, it can have well over 3 million parts. And even larger 747s can have 6 million parts. Now, these many parts make engineering utterly complex, right? And hence it is important to have a synchronized and digitized engineering plan. Some of these aircrafts actually take years to be just designed so that it can actually spin out the first prototype. That's how complex engineering is. Let's talk about another critical problem in engineering, and then we'll talk about how AI is solving them. Okay. Another problem in engineering is a lot of this is driven by legacy systems. Remember, engineering firms, these are very old, established firms. They have legacy systems like legacy ERP, legacy designing tools, CAD tools that have to talk to each other. And sometimes it's not even possible to talk to each other. Organizations are trying to upgrade their systems, but there are critical challenges. Now, there are key questions to solve when you're actually upgrading your legacy system. Number one, is it possible to migrate my legacy data to the new system? In many cases, the answer is no, sadly, because engineering designs are created, for example, in papers, right? We've seen clients where mechanical designs are 2D drawn on paper because they are like 30 years back. New systems be compliant to my processes? That's another question. The regulations are changing every second due to geopolitical situations. Will my new systems be compatible to those processes? Okay. And the third, which most probably is least talked about, but in fact most influential, how will people adapt to my new system? My people who are actually working in these organizations, are they flexible enough to adapt to these new systems? These are some of the key questions that we should solve. Okay, I leave these questions to your food for thought for a minute. And let's jump to a case study. Okay. Now, this is a global energy and utilities company that we'll talk about. And why should we actually talk about this case study? The company is a global leader in energy and utilities sector with approximately $34 billion in revenue, one of the market leaders. Okay. It is a pioneer in the industry to leverage AI throughout its product lifecycle. Okay. Engineering, manufacturing, maintenance, and operations. Okay. And we'll see real world application of how AI has smartly transformed their businesses. Okay. And it's solving end customer problems. And that is why this company, which was once loss making, has become profitable. So let's deep dive into this case. Now, what was the drivers for the change in this company? Number one, cost pressure. Okay. Sustaining high cost of operations. Because this was global in nature, there was a high cost of operation involved at every step in this company. There was the cost of manufacturing was very high for this company. Okay. Regulatory pressure. There was pressure by governments across the globe to adhere to their energy norms. Okay. For example, Europe wants net zero. They want zero carbon footprint. India has different standards for carbon footprint. Okay. And hence, to avoid penalty, they had to cater to localized regulatory footprint. Let's talk about peer pressure. As with any other global organization, there was stiff local competition. Local competition is often preferred vendor locally because of go global, local challenges, policies that various governments have. So localization and competition from local was a big problem for this company. Again, with these, the choice of deciding between cost leadership, thought leadership, and quality to maintain competitive edge is always a difficult question. Okay. And last driver for the company was safety and health. There was increased safety issues at work sites. Now, what does this mean? Safety issues means worker deaths, workers getting injured at work sites, leading to protests, government suits, union demands. These were all a big concern and money loss for the company and a big driver for a change. Okay. Now, how did the company react to this? Okay. The company knew they had to change because they were going in the loss. Okay. Number one, they did an end-to-end value chain assessment. Okay. What were the challenges across the value chain? Sales and marketing, product engineering, supply chain and procurement, manufacturing, and operations. Okay. Sales and marketing, it is difficult to optimize sales quotes, right? Based on historical quotes. Let's say you're reaching a new customer. How do you optimize your current sales quotes based on learnings from previous quotes? Are your sales agent trained? Their sales agents were not trained to leverage latest technology. Okay, their sales, engineering, and manufacturing systems were not linked to each other. And this was a major problem because they couldn't have latest engineering data to support their sales quotations. Okay, product engineering. They were unable to optimize their product designs based on customer feedbacks. They were not able to leverage existing historical designs to generate new products. This was again a problem because their product time to market was very high. Okay, they had a very lengthy prototyping process again. Let's talk about supply chain. There was a huge gap in inventory. There were supply chain disruptions globally, and which was further worsened by the ERP systems that were not linked to other systems. Okay. And manufacturing wise, the production lines, they were not able to optimize them to the full capacity. Okay. And which led to order fulfillment delays, also led to some of the worker safety issues. Okay. From an operations side, equipment failures was a big setback for the company. Lot of difficulty in predicting when the equipment will fail. Okay. Also, if my equipment has been failed, we need to service it. And tracking equipment service catalogs was another challenge for them. Okay. Third challenge is physical presence of engineers were needed for every small repair. Okay. This was a huge cost setback for the company. Now, this is just a snapshot of what was a full list of problems, but this gives a gist of the magnitude of the challenge that the company was facing. Okay. The next step was to look at these problems and solve them and categorize them by people, process, and technology. Which problems are people-oriented, process-oriented, and technology-oriented? Now, once you've sorted these problems, the process and technology problems were solved through AI. How they were approached, let's look at that. Building an AI factory. Okay. The company actually built an AI factory to solve the problem. Okay. It was a center of excellence inside the company. They had their motto: accumulate, simulate, and circulate. Okay. When they were accumulating, they were hearing from the customers, internal and external. What are the complaints, the feedbacks, innovation sessions internally? All led to a huge amount of use cases that they needed to solve. Simulate. During this phase, they would score each use case in terms of priority. Okay. Now, once they have prioritized their use cases in the AI factory, they will build a SWAT team to actually go ahead and simulate those use cases. Okay. Circulate. Now, this is when the socialization of the use case across the company happens. They would demonstrate the AI use cases to the concerned department. They will monetize these use cases, both internally and externally. And through this, the company was able to solve majority of technology-related issues. Okay. AI factory ensured standards, which was very important because we want the same AI standards across the organization rather than leveraging different standards. Okay. And this led to monetization of not only the tools, but reduction of cost pressure that the company was facing. Okay. Let's look at some of the examples of use cases that was solved. Okay. I'm going to play this video. Let's hope the audio is enabled.
AI features.
Just taking a pause here. Are you able to hear the audio?
Yes. Yes, Vivek.
Asset inspections are necessary for safe, reliable, and compliant operations in industrial settings. Yet most operations still conduct these manually, consuming days or even weeks of valuable worker time. And manual inspections can put workers in harm's way around elevated heights, difficult to access areas, and electrically charged equipment. Plus, the growing use of wind and solar assets that are spread over miles makes manual inspections difficult to scale and therefore unsustainable. While traditional alternatives like sensors are an option, they don't help with visual inspections. They can't identify surface defects such as corrosion. They fail to offer visual context. They're often expensive, and they require asset downtime for installation. Introducing Autonomous Inspection, an AI-powered computer vision software that's part of GE Vernova's APM software suite. It helps transform the traditional inspection process. Autonomous inspection uses cameras and artificial intelligence to automate the manual inspection process. The result? Faster, safer, and more cost-effective inspections. So, how does this work? Images of assets are captured by fixed or mobile cameras and sent to the cloud to be analyzed by Autonomous Inspection's specialized AI machine learning models. AI findings can directly trigger alerts or recommendations if an anomaly is detected, or the findings can go to a team member for prior approval. Packed with powerful AI features to automate inspection workflows, Autonomous Inspection can automatically identify assets like pressure gauges and pull readings from them, detect defects like corrosion, as well as classify them based on severity levels, trigger alerts, and integrate time series data and insights with select GE Vernova's APM applications. Automate image data management for later reference and analysis. With Autonomous Inspection, switch from spending days or weeks performing manual inspections to automating inspections in mere minutes to hours, saving costs and ensuring better asset uptime. Hazardous inspections or unnecessary inspection-related travel to boosting worker safety and productivity. Poor visual context to rich visual insights now available within your GE Vernova's APM. Enable faster detection and response, improved worker productivity and safety, and better asset and operational outcomes with valuable visual insights. Don't just improve inspections, transform them with AI-powered Autonomous Inspection.
Well, okay, I'll pause this here. That's going to the end.
From GE Vernova.
Okay, so this is how they did it. Okay, they created a digital twin using sensors of all their assets, and they captured data from all these sensors and trained models to use those data to perform, let's say, a detect corrosion, thermal profiling, right? And push this results to dashboards. Now, this was extremely important for the client and the client end customers of these clients. Okay, what happens there is during asset monitoring, a lot of these time is spent on actually identifying to fix the problem. Now, this was drastically reduced because your time to detect or predict a failure was significantly reduced. Okay, so this was a real world example which really impacted across Europe and Asia, how the client and their end customers reduced their inspection times, okay, using AI. Let's talk about another example. This example is again very famous globally because this is about building digital twins to drive energy efficiency. Some of you may not be familiar with digital twins. I can talk about digital twins later, but let's see this video first.
The electricity industry is entering an unprecedented time of disruption and change. Decarbonization is driving the adoption of decentralized renewable energy, which in turn brings complexity to the grid with a multidirectional flow of energy and an increasing number of connected devices. Utilities are looking to digitalization to increase innovation, reduce cost, and manage risk. Traditionally, electric utilities have operated in siloed organizations where each department, for example network design, has a separate and specific view of the grid. In order to meet the challenges of the modern grid, utilities need one comprehensive view. This approach reduces inefficient business processes and eliminates manual data sharing. And as a result, utilities can harness the benefits of digitalization and provide more innovative services. The Network Digital Twin from GE provides a comprehensive view of the grid combining GIS, EMS, and ADMS, all powerfully shared across the utility. The network digital twin is software that connects physical systems on the grid with the capabilities of the digital world. It is the digitized version of the living organism that the modern grid has become. Network digital twin accumulates data over time about the structure and location of assets, their operation, and the environment in which they operate. On top of that asset data, valuable intelligence is developed using analytics, physics, and continuous machine learning. Past and present asset performance and operation are stored as part of the digital twin and can be used to predict future outcomes. With the network digital twin, multiple data sources can be fully leveraged to simulate and predict how the grid can be optimized. This puts an end to hunches and guesswork. Field crews can be dispatched to the right location with the right information in order to rapidly fix what's broken and optimize network reliability. Asset maintenance moves from reactive to predictive. And utilities gain a forward-looking, fact-based view into where they need to make capital investments in order to remain resilient, increase efficiency, and provide better customer service. Network Digital Twin from GE breaks through organizational data silos to digitally transform your grid.
Okay. So what was this use case all about, right? This use case was about how do we actually drive energy efficiency using digital twins. What is actually a digital twin? Now, a digital twin is actually a simulation of a physical product in a digital world. It can be anything. Your pen can have a digital avatar in your computer. That's a digital. But does that mean it's a digital twin? Having a digital avatar that reacts to a change in a physical avatar is what is a digital twin. For example, if you are holding your pen and if the digital avatar says or points that with the pressure points where you're holding the pen, that becomes a digital twin. Okay. Now, having a digital twin has several advantages. And let's talk about a process digital twin. In manufacturing process, digital twins create, let's say you model the manufacturing scenarios. Plant operators can ensure they're looking at things virtually to simulate cost, volume objectives, and not have to do trial and error with actual physical product. So it's a highly efficient way of improving manufacturing quality. Grid digital twins, okay, in real time view what are the changes of in power grid, right? So that you can predict your maintenance, you can predict power outages. Operators can simulate the behavior of grid under weather conditions across globe. So somebody can be sitting in a remote village, let's say in India, and predict the weather patterns in North America and control the grid at a specific location in North America. That's the power of digital twin. Okay. Now that we've seen two examples in the energy sector, okay, I know we have 10 minutes. Let's talk about another great example of an aerospace major. We talk about Airbus. It's no secret. It's all publicly available information. Okay. And this is again about digital twins and how Airbus is actually leveraging. In fact, it's a pioneer in leveraging AI and digital twin across its value chain to develop quality aircrafts, okay, which its competitors are still trying to replicate. Okay, so I explained earlier, digital twin is more than just a digital model. It's a dynamic living virtual replica of your physical object. Okay, you optimize processes at every step of product lifecycle, from initial design, manufacturing, and ongoing operations and maintenance. So it is at every stage. Okay. company actually got teams working end to end in transforming how digital twin should work at each step, right? Number one, making information about aircraft and their productions readily available in some digital form, because the basis of digital form is digital data. Okay. Second, 3D models. This is the core of digital twin. So you need to have strong 3D models that actually represent your aircraft and each component of aircraft. Okay. And at the end, you need to tie all these things together. So you need a unified approach, a digital architecture. Now, platforms like 3D experience provided by Dassault Systems and SAP were critical to achieve this goal. Okay. Now, how did this happen, right? You leverage smart simulation tools and robots across the value chain, right? That can predict how designs will perform under various conditions, simulating weather changes, simulating, let's say, a rain, a thunderstorm, a sandstorm for working in deserts, a snowstorm. So all these weather changes and how it, let's say, has an impact on its wings, engines, flaps, fuselage of the aircraft. All these were simulated, and you could actually see the strength of materials and assess, let's say, I need a better composite to design a fuselage or a body of an aircraft versus the current material used. So this is where AI is actually helped Airbus enhance its aircraft designs. Okay. Second, it boosts efficiency and minimizing paperwork. Okay. So paperwork, AI was automatically able to simulate and generate regulatory documents. So instead of people going manually and typing out those regulatory documents and filing it, let's say, to a French government, AI was able to do that with accuracy and minimal errors and submit it. Boost efficiency. All these work happening virtually, and with the help of supercomputers and quantum technologies, AI was able to simulate these real world challenges faster, rather than having to simulate these challenges in real world and having aircrafts flying and testing under those conditions. Virtually testing these scenarios was much more efficient, cost efficient, and faster. Okay. All these results were available in connected devices such as tablets, smart glasses, right? And virtual trainings for the operators were even provided, right? So this became a one-stop show for Airbus to actually talk to everyone in its organization. Okay. So this was, again, an industry example which has become a pioneer in how a company can leverage AI and boost its engineering end to end. Okay. I had this video. I know we short on time, but I can paste the link for this video. This is a very long video for Airbus, and you can watch it. It's a very nice video which talks about how Airbus has partnered with Dassault Systems and some of the other industry leaders to actually build a partnership for developing better aircrafts. Okay, so this is a great example and provides some insights on that. Okay. Yeah, that's it about me. Happy to connect with everyone. Questions?
Just so you all know, people, you can simply unmute and talk. You did a lot of heavy lifting, Vivek. Take some time to process the information. But
No problem. Happy to connect with everyone. Please send me your questions
but this
offline.
is all
Happy to answer
hardcore
them.
data, which is like just talking off the ground, organic examples, which is like just awesome. And also, especially the Airbus ones, right? You can't afford to really break as many of those Boeings. So I think very, very pertinent area.
Thank you.
Then you guys
Thank you, everyone.
Vivek, seems
got
like there
a
is a question
LinkedIn.
on the chat.
Yeah. Are there any case studies? That's a question.
No,
No,
before
no.
that,
Kiran is asking.
how are
There's one
Indian
more.
power disco are using digital twin concept? Are there any case studies?
Indian companies, yes, a lot of Indian companies are using digital twins. And a very nice example of this is our own Hindustan Aeronautics based out of Bangalore. They're building their LCAs, their LCH. It's all done using digital twin technologies and using the Dassault system platform as well. So it's a great example that you should actually read about, and it's something all of us to be very proud of.
Okay, then I think it was Hiren who said, are there any case studies? LCA Tejas. Well, it has taken, okay, to build and test. LCA Tejas, it has taken 30 plus years to build and test.
That is true.
Will this be shortened now with the advent of technology? And
Actually, a lot of the challenges is due to the technology availability as well. India is growing in this demand, and aircraft is controlled technology that India is trying to develop in-house. So it's a very regulatory driven market. So people have to understand that a lot of these things take time, and there's a lot of politics behind this as well. And it's not as simple that we can go and develop an aircraft in, let's say, a few years. It is what it is.
Hi Vivek. A small question. How is this used in supply chain management? You are a bit very something. You throw some light on that because I'm
AI
from
in
the
supply chain. Yes, AI is leveraged heavily in supply chain. We have various tools that can integrate. Let's say, I'll give you a use case: weather patterns, and predict how you should whether you should actually ship your goods to that particular location at that particular time or not, whether it's safe for you, whether there'll be rainfall along your routes. So that these are some of the real world use cases that's happening. Using maps, you can simulate what's the best possible route, what's the best possible routes in terms of safety, in terms of cost. So all that can be simulated for supply chain to happen smoothly across your organization. Again, a lot of things are happening in this area. These were some of the examples that I had in mind.
any most novel use case according to you? It seems
For
like you
supply
have
chain,
across, like really open. According to your experience, what has been like very, very novel use case?
something that I had done recently for a very famous consumer goods company recently here in North America. Again, they're very old, and a lot of their data, product data, in form of chemicals and it's a shampoo manufacturer. So bottles, designs, they were all paper because they were all 30 to 40 years old. They were written by hand. Okay. Now AI had to be leveraged to, number one, extract those information, design those, convert the 2D paper drawings to 3D models, and load them into the systems for tracking purposes. That was, I believe, one of the most novel use cases that was implemented very recently. So it's very fresh in mind. And actually, it had great benefits. They were able to leverage the power of historical data, even if those products were obsolete in market. what were the learnings from their product data is right now readily available for those companies.
Wonderful. Thank you for sharing.
Yeah, sure. All right. Thank you, everyone. Have a wonderful day.
Thank you so much. Anyone has, let's say, closing remarks, people?
And
Just there you go.
Vivek, thanks for your session. This was really helpful and with covering different use cases from different sectors and industries. Thanks for thanks for taking your time.
Oh, pleasure's mine. Thank you.
This was like rainbow on the entire gamut that we've covered throughout. Thank you.
Sure.